Um, sa previous nga module, we had the concepts underlying these methods of analysis. So, ang atong gidiscuss sa whole midterm duration were just concepts. Okay? Mora to ang concepts nga magamit nato to understand these analytical methods. Okay, so for this lesson, we will have the analytical methods, especially the classical methods of analysis. So remember that the goal of analytical chemistry is to identify, to qualify, and to quantify. Okay, remember that is our goal. So that is why we have qualitative and quantitative analysis. Now, analytical chemistry, as you know, it deals with methods for determining the chemical composition of samples of matter. Okay, so ang qualitative method, it yields information on the identity of that substance. Whereas ang quantitative method provides the numerical information as to how much of that substance is present. Okay? So there are actually two types of two methods of analysis in analytical chem, in the whole of analytical chem. So we have classical method and we have instrumental method. So ang present day, so if you work in labs that have advanced technology, most of the labs you won't have to use the burette, or you won't have to use you won't have to do the titrations. You just need to like click some buttons on a machine. Okay, so that's the present day instrumental analysis. It's what we call as instrumental analysis because we now use some high-tech instruments. So the advantage of those are better and faster. It could produce more data with just in a small amount of time. Miniaturization, so of course you only need just that one machine and it could already produce a lot of things. And of course it could give you better data processing methods. That's what we call as chemometrics. So it's like the statistics in analytical chem. It could already give you those things. That is for instrumental. We also have classical methods. Now, ang classical methods class, the advantage of classical methods is that because you're not using the machine, you're using it kanang wet methods ba? Wet methods, which means that you do it in the lab, like you do the titration, the weighing, the dissolution. You do all those things. We do all the wet methods. And the advantage of that is that you can understand the principle. Because with instrumental, you just know how to which button to click, and then it will give you the result. But for classical, you have to know what to do and how to do it. Okay, so that is why that is the advantage of classical. You learn the principle. So when the machine bogs down, then you will know how to work it out by principle because you know the classical method man. Okay, so in universities, they actually teach the classical methods. When personally, we weren't taught about instrumental methods that much. Kanang mga AAS, we weren't taught about it because we were taught on the principles, the classical methods. And it's an advantage because when we get to the instrumental portion, it becomes easy. So in the classical methods class, it involves the separation of analytes by precipitation, extraction, or distillation. So from your in-org, you've done all these things. You've done precipitation, you've done extraction, and you've done distillation. Diba? Qualitative analysis by reaction of analytes with reagents that yielded products that could be recognized by their colors, boiling or melting points, solubilities, optical activities, or refractive indices. So you have to change, for example, your analyte is gold, for example, gold analyte in an ore. So you want to know how much of that analyte is present, or you want to know if gold is present in that ore. So you have to convert that ore into something that would give you a property of gold. Like for example, you need to extract the gold from there, and such that the end product that you will have will be able to give you a specific property of gold. Okay, for example, the refractive index of gold, something like that, or the melting points. Okay, so for quantitative analysis, it could be done by gravimetric or titrimetric techniques. So these are the two classical methods of analysis, gravimetric and titrimetric. So for gravimetric methods, the mass of the analyte or some compound produced from the analyte was determined. So it means that you have to weigh something. That's why it's called gravimetric, because the end product can be weighed, and that weight of the end product could give you an idea. It should be stoichiometrically related to the analyte that you desire. For titrimetric, the volume or mass of a standard reagent required to react completely with the analyte was measured. So it's not the analyte that's directly measured, but it's the standard reagent, and it could be a volume or it could be a mass. Okay, so there's the difference. So for instrumental methods, you measure the physical properties of analytes such as conductivity, electrode potential, and a lot more. Okay, so these are for instrumental methods. So let's proceed with the first type of classical method. So gravimetric analysis. You've actually encountered a lot of gravimetric analysis problems in the assessments from previous assessments. Okay, so for gravimetric analysis, this is a technique in which the amount of an analyte in a sample is determined by converting the analyte to some product. Okay, so the analyte is converted to some product wherein the mass of that product can be easily measured. So you can just measure the mass of that product. Okay, so you measure the mass of the product, and then so the analyte is the one that is to be analyzed. Okay, you already know this. The analyte is something that you want to find. Okay, and then so overall, gravimetry is really simple. It sounds simple. So the advantage of this one is if you did the whole gravimetric analysis correctly, it's highly accurate. Okay, and it requires minimal equipment, because usually ang imong buhaton is precipitate, dissolve, filter, dry. Okay, those are just the things that you need to do, diba? It requires minimal equipment. And then ang disadvantage of this one is that it really requires skills, and of course it's kanang slow, because you have to dry, you have to wait for how many days actually, because you need to kanang ipa-constant pa na nimo ang wait. Okay, so you have to wait for days. And then ang basic ra gyud nga buhaton sa gravimetric analysis is you need to convert the analyte. So you need to convert the analyte into solid. So meaning ipa-precipitate ba ron nimo, the analyte is in solution, then you need to precipitate it with something, and then imo i-filter, and then imo i-weigh. And of course, if gawin nimo, there's the process nga mo nang slow siya. Kay inikawin nimo, you have to weigh nga wala na inahabilin nga liquid, di ba? Wala na inahabilin nga tubig ato, dili na siya moist, dapat completely dry na siya. So you have to weigh kanang it many times actually. And then after weighing, you have the mass of that analyte or kanang species that contain the analyte. So you can calculate via a mole map. So it means you can calculate it using the stoichiometric relationship of your analyte. So for example, if you want to determine the lead content in water, so ang lead, kining mga lead class, ang lead naturally, if it's just Pb, it's in solid form. But if it is ionic, ang lead kay charged kanina siya. Any metals, if it's charged, it means nga gidissolve na siya in something like water. Mostly it's just in aqueous. Because wala may lead 2+ nga solid. You cannot have lead 2+ nga solid, right? Because if it's solid, then that should be lead, just lead alone, Pb. Okay? So meaning if you have this lead 2+, it should be in solution. So if you want to determine the amount of this lead 2+ in solutions, for example, in your tap water baron, you want to analyze the lead 2+ in tap water, then if you want to use the gravimetric analysis, if you want to use this method, then what you need to do is to precipitate the lead. So meaning you need to find something, some reagent that could precipitate, that will react with lead such that inika-react nilang luha, mo form siya og precipitate or solid product. And of course, ang requirement is that once it precipitates, it should not be soluble, di ba? Kaya if soluble, mubalik na po siya dissolve. So, if you precipitate lead with a reagent that contains chloride, so it could actually form lead with PBC to form, it could actually react with lead 2+ to form PbCl2, which is a precipitate. So, meaning, kung kato imong water nga solution, kato imong water, if this is your water nga, this is your container, this is a beaker, it contains the water, mao na imong sample, and then you think nga nani siya lead 2+, you want to know how much lead 2+ is present, then you just need to add a reagent that contains chloride, and then the chloride will form the precipitate. So nananay mo settle sa bottom dira nga precipitate, and that is the lead chloride. So whatever lead chloride that you weigh, it must be stoichiometrically related to this lead 2+, di ba? So for example, if you weigh 4 grams of this lead chloride, then that means you just use the molar mass of PbCl2, di ba? Molar mass ana para makakuha nimo ang mole of lead chloride, di ba? Grams per mole. Yeah, times 1 mole of lead chloride needs 1 mole of Pb2+, diba? So you can calculate the amount of this Pb2+, diba? Another requirement is that you need to add excess chloride to the sample such that all of this lead 2+ will precipitate as PbCl2. Because if gamay ra imong i-add, then ang tendency is that not all of the Pb2+ will precipitate. Kay gamay ra nga chloride imong gi-add. So you need to add excess jud. So okay ra nga mas masubra ang chloride kaysa mas kanang makulangan ang chloride. Because the analyte is lead 2+. You have to precipitate the analyte as PbCl2. So dapat ma-precipitate jud ang tanan. Okay? So, that's one requirement in a gravimetric analysis. Okay? So, after that, when you precipitated all PbCl2, so, of course, napa man na siya is sagol nga liquid, di ba? Napa siya sagol nga water dire. So, after precipitating, of course, you need to filter that and then ipa-dry pa nimo, diba? You have to dry this. That's why gravimetric is a slow process because you have to wait, filter and then ipa-dry pa na nimo, and then after drying, you have to kanang ipa-constant nimo ang weight. So, imo na isod sa furnace baron for 4 hours and then i-weigh nimo, ipa-cool down na nimo, and then i-weigh, and then ibalik na sad nimo og furnace, and then such that nga inika-weigh nimo is dapat constant na ang weight. Kaya if constant na ang weight sa kada weigh nimo, that means wala na gyud siya moisture nga na nisulod, wala na siya water. Okay? So that's pure PbCl2. And then the mass of that precipitate, the mass of PbCl2 will be determined. Diba? Na-determine na nimo. So, that mass will be used to calculate the amount of Pb2 plus in original solution. This amount of Pb2 plus, okay, the amount of the analyte, okay, using the balanced equation. So, what you need to do in gravimetric is that you need to have the skills, practice yung mga skills. Remember that you need to add excess of the reagent para i-precipitate na siya. And you need to weigh it such that constant na ang weight. And then you have to know the balanced equation of what you were doing. Okay? So, for example, what is the percent KCl in a solid if 5.136 grams of solid gives rise to 0.8246 grams of silver chloride? So, ang question is the percent KCl in a solid. Diba? So, meaning, this Cl, because it forms silver chloride, then this Cl comes from KCl. So, we need to know how much of this para ma-relate na to siya sa KCl. Diba? So, to do that, we have, because we have 5.136 grams of solid. So, to solve for the amount of this chloride, that's our aim pa. So, we need to solve the amount of this chloride gikan sa mass, using the mass of this precipitate. So, you have 0.8246 grams of silver chloride nga precipitate. And if you convert the grams to moles, so that's the molar mass of silver chloride, grams per mole, diba? That's grams per mole of silver chloride. So, for every 1 mole of silver chloride, you need 1 mole of chloride. 1 Cl minus, diba? And for every 1 mole of KCl, you need, there's 1 mole of Cl. Diba? So, cancel, cancel. Now, you have mole KCl. But, you're asked for percent KCl. Diba? So, we need to convert this to grams. So, you need to use the molar mass. So, that's grams KCl per mole KCl. So, that's molar mass. So, cancel ang mole. So, now you have grams KCl. So, after solving for this grams KCl, this will give you grams KCl. After solving for the grams KCl, you can now find for percent KCl, which is the grams KCl, kini nga grams KCl, this one, divided by the mass of sample. Kay percent KCl in sample in the solid man. So, divided by the mass of solid. Times 100 because it's percent. And then you get here the percent KCl. Diba? So, you can solve for the amount of the analyte gikan siya sa weight or the mass of the precipitate nga na-produce. Okay, so it gives you the mass. So, you always start with this one. So gikan ka sa mass sa imong precipitate, and then you relate that with whatever is present in the equation. And sometimes it's direct. So ang analyte nimo is naa dito sa equation. Sometimes ang imong analyte, which is in this case KCl ang imong analyte, ang imong gipangita, it's KCl. So sometimes, like in this case nga ang analyte will be related to what is in the balance equation. So for example, for every 1 mole of KCl, there's 1 mole of chlorine. Okay? There are 2 types of gravimetric analysis. We have combustion analysis and we have precipitation. So sa combustion analysis, both of them are gravimetric. So sa combustion analysis, the common method used to determine the amount of carbon and hydrogen, this is combustion analysis. Another modified method called the Dumas method can also determine the amount of nitrogen in a sample. So this technique is accurate and usable with a wide range of compounds. So we will not go into detail with this one. So often one of the first methods used to characterize a new compound. Okay, so yes, in organic class, if you notice carbon and hydrogen, these are organic. These are the elements present in organic compounds. So in organic class, the first step jud is to do combustion analysis in order to know kung unsa ang mga elements nga present sa imuhang unknown. So in the combustion analysis, sample is heated in presence of oxygen. So it's combustion. That's why it's called combustion. So kung imo na siyang i-oxidize, that's what we're doing man. It's we're oxidizing the sample. So ang tanang carbon will be converted to CO2. Tanan nga carbon sa imong sample. So whether this is glucose or whether this is bisag C12H22O11 pa na, that's sucrose, diba? Or C6H12O6, that's glucose. So tanan nga carbon nga present sa sample will be oxidized. So in the presence of heat and this catalyst, platinum nga catalyst, so they will be converted. All the carbon will be converted to carbon dioxide. So ang hydrogen, on the other hand, ma-convert po siya into water. So ang product sa imuhang ang product sa combustion ani is carbon dioxide and water. Okay? So we have several catalysts nga makapa-enhance speed. So we have this platinum, copper oxide, lead oxide, ug manganese dioxide. So these are just catalysts, okay? They do not affect the stoichiometric equation. They only affect the rate of the reaction, okay? So as these products are formed, remember in combustion the products are in complete combustion the products are carbon dioxide and water. So as these form, you leave the sample and flow through a series of chambers. Okay, so these chambers will contain chemicals that bind one or both of these products. Okay, so for example, ang nasa chamber, like for example, kini mao ni inani ang chamber ha. So for example, the combustion happened here, so ang kining product CO2 ug H2O mo flow sila dire. Okay? And then ang kini siya class, kining surface ani. Sa sulod ani, so sulod nga surface ani, mura na siya tube. They have these things. They have these compounds. So P4O10, this can absorb H2O, ang P4O10. This will absorb water. Ang ascarite can absorb CO2. Yeah, we have also ascarite sodium hydroxide coated non-fibrosilicate. Okay, so mao na ang components sa kini nga chamber. This is for combustion analysis. Okay, so this is the process. So after na burn, meaning after sa combustion burning, it's combustion. So we remove the P4O10 and ascarite cartridges. Nya i-weigh na nato ang ascarite kani nga cartridges. Remember nga this will absorb water, nya absorb siya CO2. So meaning ang imong giweigh is P4O10 plus water niya, ascarite plus carbon dioxide. Diba? So if ang C ug H, if there's C and H present in that sample, sa sample nga imong gi-burn, meaning you will expect nga mo increase dapat ang weight sa P4O10 ug ascarite. So ang requirement na class is you need to weigh this before the reaction ha. You should have the weights of these absorbents before the reaction. Okay? Now, ang amount of carbon and hydrogen in the original sample is determined from the amount of sample burned and the change in weight in each cartridge. Diba? Because iyan namang gi-absorb sa cartridge ang carbon o ang hydrogen. Diba? So, not exactly carbon, but carbon dioxide and water. But those are stoichiometrically equivalent to carbon and hydrogen respectively. So, for example, a mixture weighing 7.290 milligrams contained only cyclohexane. Okay? So, cyclohexane, C6H12. This is not cyclohexane, but cyclohexene. Okay? And oxirane, C2H4O. When the mixture was analyzed by combustion, 21.999 of CO2 was produced. So, you know what's produced. Find the weight percent of oxirane in the mixture. So, first step is to create the balanced equation. So what happened during the combustion? Okay, so nakay mixture, mass of mixture is 7.290 milligrams, and it contains cyclohexene and oxirane. Okay, so when the mixture was analyzed by combustion, that's 21.999 milligram of CO2 was produced. Okay, so let's first find the mass of, let's first find the balance equation. So we have C6H12, and if that's oxidized, you form CO2 and H2O. And then when you have C2H4O, you oxidize that, you should form CO2 plus H2O. So we need to balance this equation. So we have 6 carbon, we have 12 hydrogen, so this should be 6 hydrogen, and then we have 18 oxygen, so that should be 9, right? So that's already balanced. Second, we have 2 carbon, so duha ka carbon. We have 2 hydrogen, we have 4 hydrogen here, so we need to have 2, and then we have 4 plus 2, that's 6 oxygen, but here we have 1, then 2, 3, so we need 3 more, right? So if we use 5/2, that's 5 oxygen plus 1, that's 6 oxygen. So this is already balanced. Okay? So it has produced 21.999 milligram of CO2. So meaning, because it's 21.999 milligram of CO2, that 21.999 is a mixture of this CO2. Gikan sa, it comes from the combustion of this is cyclohexane, sakto cyclo man eh. So it comes from the combustion of cyclohexane and oxirane, diba? So this gives us 21.999 milligrams. Okay? So if you relate these, it means that 21.999 milligram of oxirane should the 6 part of 8, diba? The total of that 6 total aning duha is 8 CO2, diba? So 6 of those CO2 must come from C6H12. So this must be how much is this? This should be 21.999 times 6 divided by 8. So 16.499 comes from, this is milligrams of oxirane, CO2. Sorry, this is CO2. Comes from C6H12. Whereas this 21.999 minus 16.499 comes from oxirane, C2H4O. Diba? So meaning, what comes from oxirane, the amount of CO2 that came from oxirane minus 21.999. That's 5.499. 4998. Diba? Milligrams of CO2. So, you can use this one to calculate for the amount of oxirane. So, if you have 5.4998 milligrams of CO2, that means this is from oxirane. This equation, that means you have molar mass of CO2, which is milligrams per millimole, times there are 2 millimole of CO2 for every 1 millimole of oxirane. Diba? Yeah. So, cancel ang millimole, cancel ng milligrams, times, you need to use the molar mass of oxirane, diba? Which is 44. That's 44 here. 44.053 oxirane per millimole of oxirane. And this will give you milligrams of oxirane. Okay? And if it's, because it's asking for weight percent, then you can use percent of oxirane will be the milligram oxirane per 7.290 milligram of sample times 100. And you get the percent oxirane in the sample. Okay?